this is our Team3 Project2. For our Project 2, we are trying to find the TV anywhere. For this company, we're trying to do a fraud detection for them. So for TV Anywhere is an audio digital video service for paying cable TV customers. It's very similar to the Netflix and the Hulu. The logins are routinely shared, which means you may access your account, same ID, with different IP addresses. You may use it in your workplace, or someone else or your friend, your family use it from other places. So in this case, for one ID account number, it may generate different IP addresses. So in this case, we're using the island method, which we learned from our textbook. So our data is large. Our data is 83,000 nodes for 1 day of usage. For this such a large network, so we're gonna get rid of we're gonna try to find the sub network from it. Well, first of all, we have to separate it into the bipartite network with top nodes is ID and the bottom node with login ID. Top node with IP address and the bottom node with login ID. So the IP address we are mainly focused on. So if they are like sharing with different IP addresses with the same login ID, then we can draw the network from there. Well, first of all, we transform this 83,000 nodes into the CSV file so that we can access easily by Python. Here's some examples for the IP addresses and login ID. And also, we're using the network X graph function to create the bipartite network. So we use add nodes from and for the IP addresses and login ID. And also from the initial bipartite network, we also separated into the projected graph or projected network for the IP address and the ID account. And then in this is really important because later on we're gonna using the island method from a projected graph instead of a simple graph. So here's just some examples for the IP address. Also, this is IP address. So for this IP address, which means there are two different IP addresses with weight 1, which means they share the same account. They share the same one. So there are some examples. And also we did a degree centrality. So that's our first table. For degree centrality, the weird thing is we find the first IP address which has 254 degrees. And all the others only between 34 to 36. This is weird because for this IP address has such a high degree, it will bring us to a caution. Well, first of all, it may be some people they're using the different IP addresses in the same maybe company they use it, but still that definitely it's gonna be a bias, or it's gonna be like a fraud because this number is too high, which seems impossible for 254 different IP addresses and they share the same account. So this gonna be we have to pay attention to this IP address. And then come to the water levels, and this is from our textbook. So we use it. We also use it for our project. So for this table right here, is a JSON table and the node with associated weights. With 0, 0 there, which means they do not share the same account. And later on, we're going to use this information to find our sub-network for our huge network. So we'll reduce them. So now, here, this is just some examples for degrees. It's a 5, 1, 3. So all of them with the numbers, which means they share the account number with different IP addresses. So now we're gonna trim the edges. So when the weight is equal to 1, so any weight is more than 1, we're gonna add edges. So greater than or equal to 1, actually, we're gonna add edges to our graph. And so here is gonna be some examples. And then we come to the Allen method. Once we use this Allen method to get a reasonable step in iterations, and then we find out actually it's our final analysis. There are only 119 share of a login with another IP address. Well, this is not bad actually compared with our 83,000 nodes for a day. So there's only like less than 1% per day. And 35 such islands exist in the network. So the word level, which is 1, that means that for the 119 share, they share one other location. So it could be work or like another Wi-Fi network in the same household. So this one will not bring us to caution. Definitely, it's reasonable. And similarly for 44, there are 44 shares, and with across 14 islands, they're sharing at the same level. So in this case, I think for this one-day usage, it seems reasonable for the sharing, but still, if we back to the degree centralities, this one right here, 44.205.194.218, this IP address will bring us to caution. So we may take a little bit time to take a look at their sharing because they have 254 degrees and edges to share. And again, from here, we have 83,000 network at the beginning, but we use the edge weight to cut our network into a smaller one. So without any sharing, we're gonna get rid of them. Get rid of the IP addresses. So if they appear to be 0, then we're gonna get rid of it. So in this case, we'll shrink our network to an even smaller network. So it'll be much easier to analyze. This is our project 2, actually, project 2.